We are going to start now the lecture 6 of chapter 5 class 11th mathematics, complex numbers and quadratic equations. In this lecture we will talk about some details related to the quadratic equations. Some of the facts we are going to discuss over here, these are from the previous classes that you have studied, and a few new things we will learn about the quadratic equation. These are a bit advanced thing that we will learn about the solutions of quadratic equations. Now we start this lecture with the definition of the term identity. So when we are having an expression, suppose I am talking about a plus b whole square, that is equal to a square plus b square plus 2ab. I am talking about an expression in this way. Then we can see that we have two parts of this expression. This is the left hand side and this is the right hand side, and this expression, the equality over here, the equality between these two expressions, it holds for all values of a and b. It holds for all values of a and b. So this kind of expression, it is called the identity. So we are saying if two expressions are equal for all values of x, we are talking about the equations or expressions in terms of x. So if we are writing that ax square plus bx, that is equal to say 3, and we are saying this is an identity. If we are saying this is an identity, it means that this thing holds for all values of x. This thing holds for all value of x, say belongs to R. Then we are saying two expressions are equal for all values of x, then the statement of equality between the two expressions is called an identity. So if this thing is true for all values of R x, then this statement, it becomes an identity. So the first question we have, it is based upon this definition. So this equation is given to us. This equation is given to us and is satisfied for more than two values of x. Clearly this is a quadratic equation. It can have at most, if we are talking about this is a quadratic equation, then it can have at most two zeros, or this is an equation, so we will talk about it will have two roots, but it is being given that it has more than two values of x which satisfy this equation. So it means it is being given that this is an identity, that is it is satisfied for all values of, this will be satisfied for all values of x. And if it is satisfied for all values of x and this is an identity, so what this thing gives us, that these coefficients we are talking about, these coefficients we are saying, these should be equal to 0. Only then this can hold for all values of x. So what we get is that lambda square minus 5 lambda plus 6 is equal to 0. Lambda square minus 3 lambda plus 2 is equal to 0, and lambda square minus 4 is equal to 0. So basically we are saying that lambda square minus 5 lambda plus 6 x square plus lambda square minus 3 lambda plus 2x plus lambda square minus 4, this is identically equal to 0. Identically equal to 0 means what this symbol represents, it means that this holds for all values of x, that is all these terms we are saying, all these terms should be equal to, all these coefficients should be equal to 0, only then it can hold for all values of x. And if we solve these equations, we will obtain the values of lambda as, from this equation we will obtain lambda is equal to plus minus 2. From this second equation we will have lambda is equal to 1 and 2, and from this first equation we will have lambda is equal to 2 and 3. So the common value of lambda which satisfies all these three equations, the common value of lambda we will have, that will be lambda is equal to 2. So we are saying that for lambda is equal to 2, this equation is an identity. So parameter lambda has the value 2. Now in this next question we have to show that this expression given over here, this expression we are saying this is an identity. So we have to prove that this is an identity, so we have to show that this holds for all values of x. And if we look at the terms over here, look at this term over here, the highest power of x over here it is 2, highest power of x in this term is 2, highest power of x in this term is 2. So basically if we simplify this term, this is a quadratic equation. Now we claim that x is equal to minus a, x is equal to minus b and x is equal to minus c. These are the roots of this equation. So to prove this thing, if we substitute x is equal to minus a in this, we will get it is minus a plus b into minus a plus c divided by b minus a into c minus a. We are talking about the left hand side of this equation by substituting x is equal to minus a. Next term will become 0 and this term will become 0. So the final answer we obtain it is equal to 1 and that is equal to RHS, and this value is equal to RHS. Similarly, we can show that for x is equal to b, if we substitute the value over here, the answer we obtain 1 is equal to 1, and for x is equal to minus c, we obtain 1 is equal to 1. So this thing tells us that this equation has 3 roots, x is equal to minus a, x is equal to minus b, x is equal to minus c. We are not saying that these are the only roots, we are saying x is equal to minus a is satisfying the equation, x is equal to minus b is satisfying the equation, and x is equal to minus c is satisfying the equation. But we know that this equation is a quadratic equation, and it is clear from this case that it has more than 2, it has more than 2 distinct values. We are saying minus a, minus b and minus c, which satisfy these equations. So we are saying that this is not an equation, we are saying this cannot be an equation, it is an identity. So we have considered, suppose it is an equation, but we have proved that we have seen if it is an equation it must be a quadratic equation. If it is a quadratic equation, it cannot have more than 2 roots. But we have shown that there are 3, at least 3 roots are there, So our supposition that this is an equation, it is wrong. So we are saying this is basically an identity and it holds for all values of x. Next is we have to show that this is an equation. So if we have to prove that this is an equation, we are talking about this term over here, we have to prove that this is an equation. It means that we have to show that for some value of x it is not satisfied. So suppose we are substituting x is equal to 0. If we substitute x is equal to 0 in this equation, then we get it is 0 square minus 0 plus 2 is equal to 0, and this thing is not true, this thing does not hold. So this implies us that this expression we are talking about, this is an equation, because if it is an identity then it should be satisfied for all values of x, but clearly for x is equal to 0 it is not satisfied, it means it is not an identity, it is an equation. Next we have some terms which you already know. First is a linear equation. So we are saying a linear equation is an equation of the form ax plus b is equal to 0, where a and b these are the real numbers and a is not equal to 0, it is called a linear equation. Then we are talking about the quadratic equation. We are saying an equation in which the highest power of the unknown quantity is 2, it is called a quadratic equation. Then we have different cases over here. First is we are writing the general term ax square plus bx plus c is equal to 0, we are talking about this equation. So clearly we cannot have a is equal to 0, a cannot be equal to 0, but we have a case when we will have b is equal to 0, we can have b is equal to 0. So the equation will be of the form ax square plus c is equal to 0. So these kind of quadratic equation, these are called pure quadratic equations, and these kind of equations in which this A is not equal to 0, B is not equal to 0, these are known as complete quadratic equations. These kind of equations, these are called complete quadratic equations. So these are just the terms, basic terms that we have. Next is, if we are given any quadratic equation, say I am talking about it is 1 plus 2x minus x square is equal to 0. So we can write this equation in the form minus x square plus 2x plus 1 is equal to 0. So we are writing it in the form ax square plus bx plus c is equal to 0. So this kind of equation we are saying, this is form of the equation, this is called the standard quadratic equation. And the root of a quadratic equation, when we are talking about a root of the quadratic equation, it is a complex number alpha which satisfies this equation. Which satisfies this equation means that if I substitute x is equal to alpha over here, that is I am talking about a alpha square plus b alpha plus c is equal to 0. If this thing holds, then we say that if this thing holds, then we say that alpha is a root of this equation. Then we know that how we solve the quadratic equations is, it is ax square plus bx plus c is equal to 0. This quadratic equation is there. Then using the method of discriminants, we can solve this equation, and the value of discriminant that we have, that is equal to b square minus 4ac, and the root of this equation will be given by x is equal to minus b plus or minus square root of d by 2a. This d is the discriminant over here. So based upon this condition, this formula, we have different cases over here. We are saying we have the equation ax square plus bx plus c is equal to 0, where a, b, c we are saying these are the real numbers. Discriminant we are saying it is b square minus 4ac, and the roots of the equation we are saying they are minus b plus minus square root of d by 2 times a. So we are having two roots basically, one is minus b plus square root d by 2a, and second is minus b minus square root d by 2a. Now we have different conditions over here is, first is if d is less than 0. We are saying if the value of d is less than 0, then this thing implies us that square root d is complex. So the roots of this equation we will have, they are the complex root, they are the non-real roots. Next case we are talking about, if d is greater than 0, if d is greater than 0, then this thing implies us that square root d is real. A and b, these are already real. So the roots of this equation we will have, this will have real roots. And if the value of d is greater than 0, we are talking about the strict greater than over here. So in this particular case, we will have distinct real roots. And the last case we have is, if the value of d is equal to 0, then in this case the roots will be minus b by 2a comma minus b by 2a. So both the roots are real, and these are called repeated, or we are saying these are the equal roots. So these cases, these are discussed over here. We are saying if d is less than greater than 0, then we have real and distinct roots. If d is equal to 0, then we have real and equal roots. Combining both these results, we obtain that if the value of d is greater than equal to 0, then we are saying that it will have real roots. So both the cases can be there, that is either the roots will be equal or they may be unequal. It depends upon the equality sign over here. Next is, if d1 and d2 be the discriminant of two quadratic equations. Suppose we are talking about an equation a1 x square plus b1 x plus c1 is equal to 0, and second is a2 x square plus b2 x plus C2 is equal to 0. The discriminant of this first equation we are writing d1 is equal to b1 square minus 4ac 4a1 c1, and discriminant of the second equation it is b2 square minus 4a2 c2. So we are saying that discriminant of both these values they are equal to this. Now if d1 plus d2 is greater than equal to 0, then this thing implies us that at least one of d1 or d2 is greater than equal to 0. So if one of these values is greater than equal to 0, it means that one of these equations we are talking about, they will have the real root. In the second case, this thing is mentioned over here, if d1 plus d2 is greater than equal to 0, then at least one of d1 and d2 is greater than equal to 0. Similarly, in the second case we will have, if d1 plus d2 is less than 0, if we are saying d1 plus d2 is less than 0, then we have at least one of d1 and d2 should be less than 0. So if one of d1 and d2 is less than 0, it means one of these equations will have complex roots. One of these equations will have complex roots. Next result we have is that if a, b, c, these are the rational numbers. We are talking about if a, b, c, these are the rational numbers, and d is a perfect square of a rational number. We are saying the value of a, b, c are rational, d is a perfect square of a rational, the roots are rational. So we are saying the roots, basically we have it is minus b plus minus square root of d by 2a, and it is being given that d is a perfect square of a rational number. It means this value we are talking about, say it is some number, say q, it is a rational number, we are writing it is p by q, say it is the perfect square of a rational number. Clearly we have b is rational, a is rational, so this whole answer we are talking about, this is basically a rational number. And in case it is not a perfect square, the root is irrational, because this b is rational plus minus, now this number over here that we are going to write in place of square root d, that is irrational, and denominator is rational, so this whole number we are talking about, this is an irrational number. And this last result, it tells us that if a, b and c, these are real numbers, and p plus iota q is one root where q is not equal to 0, then the other root must be p minus iota q. That is, the roots of the quadratic equation, they occur in as conjugate pairs. So this thing is also clear from the formula. We are saying that one root will be minus b by, we are saying that one of the roots will be minus b by 2a plus minus square root d by 2a. If we are saying that the square root d is, say, negative, we are saying it is complex number, or it is d is negative, in case d is negative, then the root will be of the form, we are saying this term we are writing it is p, then this whole term we are writing it is q. So one term will be, this whole term is q iota we are writing. So one root will be p plus iota q and other root will be p minus iota q. Similar kind of result holds if we are talking about the irrational roots. We are saying if one root of the equation is, say, p and q, these are the real numbers, and it is of the form p plus square root of q, then the other root will be p minus square root of q. So we are saying that they occur in these pairs, that these are the conjugate pairs. The roots of the quadratic equation, they occur as the conjugate pairs. An important point to note over here is that this condition is very important, that the a, b, c, this should be real numbers. We will see in our next slides that if a, b, c these are not real numbers, then it is not necessary that if p plus iota q is the root, then p minus iota q is also the root. So the condition that a, b, c should be real, it is necessary. Next is, this thing is explained over here, that if one root of the equation it is p plus square root q, then the other root must be p minus square root q. And it is important to note over here that this a, b, c these must be the rational numbers. Only then this thing holds, that p plus square root q will be one root and p minus square root q will be another root. If a, b, c these are not rational numbers, then this thing might not occur. So this condition over here, this is very important condition, that a, b, c these must be the rational numbers. Now the next result we have is, if a is equal to 1, b and c these are integers. So we are talking about the equation x square plus bx plus c is equal to 0, and we are saying b and c these are the integers, and the roots of this equation are rational numbers. So roots of this equation, they are x is equal to minus b plus minus square root of b square minus 4c upon 2, and it is given that this is a rational number. This number is a rational number, then these roots must be integers. So we are being given that this is a rational number. It means that this term we are saying this is a perfect square. So we are writing that b square minus 4c should be equal to some m square. This m we are saying this should be an integer, because b and c these both are given to be integers. Now we are considering two cases. Suppose we are saying that b is odd. So if b is odd, we will have b square is odd, b square minus 4c is odd. It means the value of m square is odd. So this implies us that value of m is odd. So what we get is the value of x we have, that is equal to minus b plus minus m by 2. Look at this term, minus b plus minus m. M is odd, b is odd. So if we do the sum or we take the difference between these two, this term will be even. So this is divisible by 2. So the value of x that we will have, that will be an integer. If we consider b to be an even number, suppose we are saying b is an even number, then b square is an even number, b square minus 4c is an even number. It means m square is an even number. So we obtain that m is even. So minus b plus minus m by 2 will be, this whole term will be again even. So the answer we will get, that will be an integer. So we are saying when a is equal to 1 and b and c these are integers, and the value of this term it is a rational number, then the roots must be integers. Next condition we have is, if we are talking about a quadratic equation, it is ax square plus bx plus c is equal to 0, and we are given that a plus b plus c is equal to 0, then 1 is the root of this equation. So this thing is clear, that if we substitute x is equal to 1, this will become a plus b plus c is equal to 0, and this thing is given to us. So we are saying that 1 is the root of this equation, and second is the roots of the equation. This equation we are talking about, they are rational. The second root we are talking about, it is rational. So if we divide this equation, we are talking about it is ax square plus bx plus c. We are saying x is equal to 1 is the root. We are dividing it with x minus 1. The answer we are getting over here, it is, we are multiplying over here, it is ax. We get ax square minus ax. This is will become minus, this will become plus. So we will get over here a plus b times x plus c. So we are adding over here a plus b. So what we obtain from this is, it is a plus b times x, and it is minus a plus b. So when we subtract these values, we will get it is a plus b plus c, and it is being given that this term is equal to 0. So what we are saying, that the other root we have, it is a x plus a plus b. We are not saying this is the root, this is the factor we are saying. So if this factor is equal to 0, so this implies us that the value of x we have, it is minus of a plus b divided by a. So clearly this number, if a and b, these are the, this is given that a, b, c, these are rational numbers, then clearly minus of a plus b by a, this is also a rational number. So we are saying the roots of this equation, they are rational. Next we are given two identities over here, so you can remember these identities. So it is a square plus b square plus c square minus ab minus bc minus ca. This value is equal to 1 by 2 times a minus b whole square plus b minus c whole square plus c minus a whole square, and this is equivalent to minus of this term. So you can remember these identities. These will be used directly in your questions. Next is find all the values of the parameter a for which the quadratic equation, this quadratic equation is given, and these are the three conditions given. It has two distinct roots. So when we are saying distinct over here, so basically we are talking about it is distinct real roots, has no roots and has two equal roots. Now it is being given that this is a quadratic equation. So the first thing we will have over here, it is that this term we are talking about, it is a plus 1 cannot be equal to 0. So this thing implies us that a cannot be equal to minus 1, because this is a quadratic equation. Now we are saying it has two distinct roots. So first of all, we are calculating the discriminant over here. It is b square minus 4ac. So it is 4 into a plus 1 square minus 4 into a plus 1 into a minus 2. So if we solve this term, we will obtain it is 4a square plus 4 plus 8a, and if we multiply these terms, it is minus 4 into a square minus a minus 2. So the answers we will obtain, it is 4a square plus 4 plus 8a minus 4a square plus 4a, and this term will become plus 8. So this is equal to, this 4a square gets cancelled, we are left with this 12 times a plus 1. Now the first part we have, it is has two distinct roots. So we are saying it will have distinct roots if the value of discriminant that we have, it is 12 times a plus 1 is greater than 0. So this implies us that a should be greater than minus 1. This condition is satisfied over here. We are saying this condition we always have, that a should not be equal to minus 1. So this condition is satisfied over here. So we are saying for a greater than minus 1, we will have no distinct roots. Second is has no roots. So if we are talking about the case that it should not have any root, so we are saying it has no real roots. We are saying it has no root, means we are saying it has no real roots, and the condition for no real roots we have that discriminant should be less than 0. Then the condition we have is plus 1 is less than 0. In this case, both the roots will become complex. So we are saying a should be less than minus 1. For this case, it has no real roots. And last we have, it has two equal roots. So when we are saying it has two equal roots, so it means that the value of discriminant should be equal to 0. So this implies us a is equal to minus 1. But we already have the condition that a cannot be equal to minus 1. So we are saying that there is no value of a, for which this equation will have for which we are saying this equation is a quadratic equation and it has equal roots. There is no such value of a. Next is this equation is given and we have to solve it. So if we look at the terms over here, it is 5 plus 2 root 6, and this second term over here it is 5 minus 2 root 6. So if we want to convert or we try to find some relation between these two, so we are going to multiply. To find the relation over here, we are going to multiply these two terms. So when we multiply these terms, the answer we will get, that is equal to 5 square minus 2 root 6 square. So this is equal to 25 minus 24, that is equal to 1. So what we have obtained is that the product of these two numbers, it is equal to 1. So we can write that 5 plus 2 root 6, that is equal to 1 by 5 minus 2 root 6, that is 1 is the inverse of the other. So this equation can be written as, we are saying this equation now, it can be written as 5 plus 2 root 6 raised to the power x square minus 3 plus 5 minus 2 root 6. In place of 5 minus 2 root 6, now we are writing it is 1 by 5 plus 2 root 6 raised to the power x square minus 3, and it is given to be equal to 10. Now if we substitute 5 plus 2 root 6 raised to the power x square minus 3 is equal to t, then this equation becomes t plus 1 by t is equal to 10. So this implies us that t square minus 10t plus 1 is equal to 0. So on solving this, we will obtain the value of t is minus b plus minus square root of b square minus 4ac by 2a. So this is equal to 10 plus minus root 96 by 2, and the value of root 96 we will have, we are saying these are the values of t we have, it is 10 plus minus root 96, we are saying it is 2 root 6, we will have this value is equal to 4 root 6, it is not 2 root 6, it will be 4 root 6 divided by 2. So the value of t that we have, that is equal to 5 plus minus 2 root 6. So this is the value of t that we have. Now if we substitute this value of t over here, we are saying once we have 5 plus 2 root 6 raised to the power x square minus 3 is equal to 5 plus 2 root 6, or we are writing this is, we have 2 roots over here, so it is plus minus of this value. So we can write this as, this is equal to 5 plus 2 root 6 raised to the power plus minus 1, because 5 plus 2 root 6, that is equal to 5 minus 2 root 6 raised to the power minus 1. So when we are having minus sign over here, we are saying we are having minus 1 over here. So comparing the powers, we will obtain x square minus 3 is equal to plus minus 1. So this gives us two values of x. We are obtaining the values of x as x square, we are saying we are obtaining the values of x square as 4 or 2. So from this term we will get the values of x as, from this value we are saying we will obtain the values of x as plus or minus root 2 and plus minus 2. So these are the required values of x in this. Next is show that if p, q, r and s are real numbers, it is given that p, q, r and s, these are real numbers, and p r is equal to 2 times q plus s, then at least one of the equation, these are the two quadratic equations given to us, it has a real root. So if we write the discriminant in both these cases, the discriminant in first case it is minus p square, it is plus b square minus 4q, this is discriminant in first case, and the discriminant in second case it is r square minus 4s. Now if we add both these values, the answer we obtain it is p square plus r square minus 4 into q plus s. This is equal to p square plus r square minus, what is the value of 2 times q plus s? So the value we have it is 2 times p into r. So this term will become equal to p minus r whole square. Now both p and r, p, q, r and s, they are given to be real numbers. Both these numbers, these are real. So it means p minus r square is greater than equal to 0. So what we have obtained, that discriminant of first plus discriminant of second is greater than equal to 0. So this thing implies that at least one of d1 or d2 is positive. If one of d1 and d2 is positive, so this thing implies us that at least one of the given equations has real roots. Now the next question we have is, if alpha and beta are the roots of this equation is given over here, it is x minus a into x minus b is equal to c. So if we write this equation in the form x minus a into x minus b minus c, we are saying the roots of the equation are alpha and beta. So any equation with these two roots, it will be of the form x minus alpha into x minus beta. So we are saying that basically this equation can be written as x minus alpha into x minus beta. So from this we are getting, this thing implies us that x minus a into x minus b, that is equal to x minus alpha into x minus beta plus c. We have shifted this c on this side. Now look at this equation over here. We are saying this equation is the equation for which we have to calculate the roots, and we have written over here this equation we are writing, this equation we are talking about, this equation we are writing in the form x minus a into x minus b. So what this thing implies is, this thing implies that a that is x minus a and x minus b are factors of this equation. So this implies us x is equal to a and x is equal to b are roots of this equation. So we have the roots of the equation, they are a and b. Next question we have is, we have to find all the roots of this equation if one of the roots of the equation is given to us. If one of the roots it is given to be 2 plus root 3. Now we know that if 2 plus root 3 is one of the roots, then 2 minus root 3 is also a root of this equation, because we have studied that p plus root q is a root, then p minus root q is also a root. They occur in conjugate pairs. Root occurs in conjugate pairs. These are also called the conjugate pairs for the surds. So if these are the two factors over here, we are saying x minus 2 plus root 3 and x minus 2 minus root 3, these are the two factors of this equation. Now if we multiply both these terms, the answer we will obtain, it is x square minus 2 plus root 3 plus 2 minus root 3x, and then it is plus 4 minus 3. So this is equal to x square minus 4x plus 1. So we have obtained that x square minus 4x plus 1 is a factor of this term. So we are dividing these values, we are writing it is x raised to power 4 plus 2x cube minus 16x square minus 22x plus 7, and we are dividing this polynomial with x raised to the power 2 minus 4x plus 1, and when we divide these two, the remainder will be clearly 0 because it is a factor over here, and the quotient that we will obtain on dividing these two, that will be x square plus 6x plus 7. This thing you can verify at your own. This thing is the part of the division of polynomials that we have studied in class 10. So, we are saying that this polynomial x raised to power 4 plus 2x cube minus 16x square minus 22x plus 7 is, this can be written as x minus 2 plus root 3 into x minus 2 minus root 3 into x square plus 6x plus 7. So, we are left with factorizing this term. So, if we calculate the factors of this term, if we find the roots of this term, we get x is equal to minus b plus minus square root of b square minus 4ac, that will be 28 divided by 2. So, the answer we obtain, it is minus 3 plus minus root 2. So, the roots of this equation, they are 2 plus square root 3, this is already given to us, and next we have it is 2 minus square root 3, then it is minus 3 plus square root 2, then it is minus 3 minus square root 2. So, these are the 4 roots of the given equation, which is of degree 4. So, we are getting 4 roots over here. Next we have is the relation between roots and the coefficients. So, if we are considering a quadratic equation whose roots are real and distinct, say we are saying, we are talking about the equation ax square plus bx plus c is equal to 0. It is a quadratic equation, means a is not equal to 0, and we suppose that its roots, they are alpha and beta, these are real and distinct roots, and we have alpha is less than beta. Then we know that the value of alpha will be minus b plus square root of b square minus 4ac by 2a, and the value of beta will be minus b minus square root of b square minus 4ac by 2a. So, if we calculate alpha plus beta, the answer we obtain, it is minus b by a. If we calculate alpha into beta, the answer we obtain, it is c by a, and if we calculate alpha minus beta, the answer we obtain, it is square root d by a. So, these are the values for sum of the roots. We write it with s, it is alpha plus beta, and the answer we have, it is minus b by a. Then next we have product of the roots, we represent it with p, it is alpha into beta, the answer we have, it is c by a, and next we have it is difference of roots, we represent it with d dash, and it is alpha minus beta, and the answer we have, it is square root of discriminant over a. So, these are some formulas that you should remember. Next is, if the roots of a quadratic equation are given, suppose we are saying that a quadratic equation is there whose roots are alpha and beta, and we have to write that equation, then the equation will be x minus alpha into x minus beta, that is equal to 0. So, if we multiply these terms, we obtain x square minus alpha plus beta x plus alpha beta is equal to 0. So, this term, if we look at, this is alpha plus beta, that is sum of roots, and this is alpha into beta, that is product of roots. This is sum of roots and this is product of roots. So, we are saying that if the roots of the quadratic equation alpha and beta are given, then we can use this method to find that quadratic equation. Next is symmetric functions of roots. So, a function of alpha and beta we are talking about, it is said to be symmetric if it remains unchanged when alpha and beta are interchanged. So, if we are talking about the value, say alpha plus beta, if we interchange alpha and beta, we get beta plus alpha, both these values, these are equal. If I am talking about alpha cube plus 3 alpha square beta plus 3 beta square alpha plus beta cube, if I interchange alpha and beta, I will get beta cube plus 3 beta square alpha plus 3 alpha square beta plus alpha cube. Both these values, these are equal. So these kind of functions, these are called symmetric functions. These kind of functions, these are called symmetric functions of alpha and beta. Now if suppose I am talking about the function alpha minus beta and I interchange alpha and beta, I will get it is beta minus alpha, and these two are not equal. So this is not a symmetric function of alpha and beta. So now what we have to do is we have to write a symmetric function. We are talking about any symmetric function is given to us and we have to write it in the form of alpha plus beta, alpha into beta and alpha minus beta. So first symmetric function we are talking about it is alpha square plus beta square. So we can see that if we write the formula in the form that alpha plus beta whole square, that is equal to alpha square plus beta square plus 2 alpha beta. So this implies us that alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta. So this is our first result. This is our first result, that alpha square plus beta square, we can write it is alpha plus beta whole square minus 2 alpha beta. And we know that if alpha and beta, these are the roots of the quadratic equation, then the value of alpha plus beta is minus b by a. The value of this alpha into beta is c by a. So if we substitute these values, we obtain that the answer we have it is beta square minus 2ac over a square. So what we are trying to say over here is, suppose we are given a quadratic equation whose roots we do not know, but we know the sum of the roots, we know the value of the sum of the roots, we know the value of the product of the roots, or we know the value of the difference of the roots, and we have to calculate the value of alpha square plus beta square. So we are saying that without calculating the value of alpha and beta, we can calculate the value of alpha square plus beta square, and for that we have to use this formula. We have to use this formula. So suppose I am talking about an equation is given, it is ax square plus bx plus c is equal to 0, a is not equal to 0, and we have to calculate the value of alpha square plus beta square. So what we will do, we are saying that we know that value of alpha plus beta is minus b by a, value of alpha into beta is c by a. We will substitute both these values in this formula and we will obtain the answer of alpha square plus beta square. Similarly, if we have alpha square minus beta square, then the formula we are using over here it is, we are talking about alpha square minus beta square, we can write it is alpha plus beta into alpha minus beta. The value of alpha plus beta we have it is minus b by a. The value of alpha minus beta we have it is square root d by a. So the answer for alpha square minus beta square we have it is minus b square root d by a square. Similarly, if we have the term alpha cube plus beta cube, if we have to calculate the value of alpha cube plus beta cube, we can write it using the formula. We are saying that alpha plus beta whole cube, that is equal to alpha cube plus beta cube plus 3 alpha beta into alpha plus beta. From this equation we are calculating the value of alpha cube plus beta cube. So we obtain the formula in this form, that it is alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. Now again we have the value of alpha plus beta, that is minus b by a. We have the value of alpha into beta, that is c by a, and value of alpha plus beta, that is minus b by a, and on solving this value we obtain the answer in this form. On solving this value we obtain the answer in this form. So we are saying if a quadratic equation is given to us, we are talking about ax square plus bx plus c, and we are being asked that what is the value of alpha cube plus beta cube, where alpha and beta are the roots of this equation. We need not to calculate the roots, value of the roots, value of the alpha and beta. We can directly substitute these coefficients over here to obtain the answer for alpha cube plus beta Next we have to calculate the value of is alpha cube minus beta cube. So the formula we have written over here, it is alpha minus beta whole cube plus 3 alpha beta into alpha minus beta. Now the value of alpha minus beta we have, it is square root of d by a. The value of 3, this alpha into beta is c by a, and the value of alpha minus beta we have, it is square root d by a, and on solving this the answer we obtain in this form. Next we have to calculate is the value of alpha raised to the power 4 plus beta raised to the power 4. So we are using the formula that alpha square plus beta square whole square, if we are talking about, that is equal to alpha raised to the power 4 plus beta raised to the power 4 plus 2 alpha square beta square. So this implies us that alpha raised to the power 4 plus beta raised to the power 4 is equal to alpha square plus beta square whole square minus 2 alpha square beta square. Now the value of alpha square beta square, we are talking about this value, we know that its value is alpha plus beta whole square minus 2 alpha beta, and we are saying this value is whole square of this minus 2 alpha square beta square. And now we know the value of all these terms, that alpha plus beta is minus b by a, alpha into beta is c by a. When we substitute these values over here, when we substitute these values in this formula, we obtain the final answer in this form. Similarly, when we are talking about the value of alpha raised to the power 4 minus beta raised to the power 4, we can write it is alpha square plus beta square into alpha square minus beta square, and we know the answer for both these cases. For both these cases we know the answer. When we substitute the value, we obtain the answer in this form. Next is alpha raised to the power 5 plus beta raised to the power 5. So to calculate this value, we are saying that if we multiply alpha square plus beta square with alpha cube plus beta cube, the answer we will have, it is alpha raised to the power 5 plus beta raised to the power 5 minus plus, we have alpha raised to the power 5, beta raised to the power 5 plus alpha square beta cube plus beta square alpha cube. So we are saying that alpha raised to the power 5 plus beta raised to the power 5, that is equal to alpha square plus beta square into alpha cube plus beta cube minus, from this term we can take alpha square, beta square common, so we are left with this alpha plus beta. And if we look at these terms over here, we have this value is alpha square plus beta square, we know the answer for this. The next term we have, it is alpha cube plus beta cube, we know the answer for this. And next these two terms, it is alpha into beta and alpha plus beta, we know the answer for this. So if we substitute the values in these formulas, the corresponding values over here, we will obtain the final answer in this form. And similarly we can calculate the value of alpha raised to the power 5 minus beta raised to the power 5 using this formula, and the answer we have, it is in this form. So these kind of problems may be asked directly, they might be of the form, we are saying that suppose we have an equation, it is x square minus root 5x plus 19 is equal to 0, and we want to calculate the value of, it is being given that alpha and beta are roots of this equation, and we want to calculate the value of alpha raised to power 5 minus beta raised to power 5. So in place of calculating the value of alpha and beta, we will directly substitute these values over here, we will substitute the values of the coefficients over here. But an important thing to note over here is that this equation should have real roots, and we are saying it should have distinct roots, otherwise there is no meaning of asking alpha raised to power 5 minus beta raised to power 5. So this equation should have real and distinct roots, then we can use these kind of formulas to evaluate the value of alpha raised to power 5 plus beta raised to the power 5 directly. Next is, if one root of the equation, this equation is given to us, it is x square minus iota x minus 1 plus iota is equal to 0, and one of its root is given to be 1 plus iota. We have to find the other root. So first thing that strikes to us is that if 1 plus iota is a root, then 1 minus iota should be another root. But this thing is not true over here, because the equation that is given to us, it has complex coefficients, and that result we are saying that ax square plus bx plus c is equal to 0. We were saying that if it has a root p plus iota q, then the other root is p minus iota q. This thing is true when a, b, c, these are the real numbers, but over here these are not, the iota is not a real number. So this thing we cannot apply directly. So to calculate the other root, we are using the result that suppose the other root we have, one root is 1 plus iota, and let the other root we have, it is alpha. Then the sum of the roots 1 plus iota plus alpha, that should be equal to minus b by a, that means it is equal to iota. Minus b means it is minus of minus iota by 1, that is equal to iota. So the value of alpha we obtain, that is equal to minus 1. So what we obtain from this is that the other root of this equation is minus 1. Next is, if one root of the equation, this equation is given, it is x square minus square root 5x minus 19 is equal to 0, and its one root is 9 plus square root 5 by 2. We have to find the other root. So to again, if we talk about the formula, the result we are saying ax square plus bx plus c is equal to 0. If it has a root of the form p plus square root q, then the other root is p minus square root q. This result holds only if a, b, c, these are the rational numbers. The coefficients we have over here, they should be rational numbers, but clearly we have over here square root 5, it is not a rational number. So we cannot use this result over here, we cannot use this result over here, and we cannot say that the second root will be 9 minus root 5 by 2, we cannot say this thing. So again we are saying that the sum of the roots, suppose the other root be alpha, so we have 9 by 2 plus root 5 by 2 plus alpha, that should be equal to minus b by a. So we are saying it is root 5. So this implies us that the value of alpha we have, that is equal to minus 9 plus or we are saying it is minus 9 by 2 plus root 5 by 2. So we are saying it is minus 9 plus root 5 by 2. So this is the second root we have. So from these two questions we can say that it is clear to us that these conditions we are talking about, that a, b, c should be real in this case and a, b, c should be rational in this case. These conditions, these are very important, otherwise these results they do not hold. Now in this question it is being given that we have two equations, one is x square plus ax plus b is equal to 0, and second is x square plus bx plus a is equal to 0, and it is given that the difference between the corresponding roots of these equations, they are same. So if we assume that the roots of this first equation, they are alpha and beta, and the roots of this second equation, they are gamma and delta, then the difference between the roots will be alpha minus beta and gamma minus delta, and it is given to be equal to each other. And we know that the difference of roots, the formula we have, it is square root d by a. So square root d in this case, it is square root of a square minus 4b by a1, that is equal to, in the second case we have, it is square root of b square minus 4a by 1. So if we solve these equations, we obtain a square minus 4b is equal to b square minus 4a. So a square minus b square minus 4 into b minus a, that is equal to 0. So we are writing it is a minus b into a plus b minus 4 into, if we take minus sign common, it is plus 4 into a minus b is equal to 0. So a minus b into a plus b plus 4 is equal to 0. So we obtain two cases over here. One is a minus b is equal to 0 or a plus b plus 4 is equal to 0. Now it is being given that a is not equal to b. It means that a minus b cannot be equal to 0 because of this condition. Because of this condition, a minus b cannot be 0. So what we obtain is that a plus b is equal to minus 4. So this is the required value of a plus b. Next is, if a plus b plus c is equal to 0 and a, b, c are rational. It is given that a plus b plus c is 0 and a, b, c are rational. We have to prove that the roots of the equation this are rational. Now if we look at the coefficients over here, it is b plus c minus a, this is c plus a minus b, and this is a plus b minus c. So if we substitute x is equal to 1, we obtain this is b plus c minus a plus c plus a minus b plus a plus b minus c. So c and c gets cancelled, a and a gets cancelled, b and b gets cancelled, and we are left with is a plus b plus c, and this value is given to be equal to 0. So we can say that x is equal to 1 is a root of this equation. X is equal to 1 is a root of this equation, and let the second root we have, that is equal to alpha. Then the sum of the roots we have, it is 1 plus alpha, that is equal to minus b by a, that is equal to minus c plus a minus b divided by b plus c minus a. And the product of roots we have, we are saying product of roots we have, it is 1 into alpha, that is equal to c by a. So it is a plus b minus c divided by b plus c minus a. So from this second equation, from this second term, we are saying we can calculate the value of alpha, and it comes out to be, we are saying alpha is equal to, we are writing alpha is equal to, in place of a plus b, we have a plus b plus c is equal to 0. So in place of a plus b, we can write it is minus c over. In place of b plus c, we can write it is minus a minus a. So the answer we obtain, it is c minus c over a. And this a, b, c, we are saying a and c, these are the rational numbers. So c by a should be a rational number. So clearly the two roots we have, it is x is equal to 1 and alpha. 1 is a rational number and alpha we have seen it is a rational number. So we obtain that the roots of this equation, they are the rational numbers, and this is what we have to prove. Next is, if the roots of this equation they are equal, then we have to prove that a, b, c, they are in HP, they are in harmonic progression. So to solve this equation, we look at the coefficients again over here, and we can see that the coefficients we have, they are a b minus a c, then it is b c minus a b, and then it is a c minus c b. So if we add all these values, we will see that this c b gets cancelled over here, this a b gets cancelled over here, and a c gets cancelled over here. So the sum of the coefficients we have, it is equal to 0. So this thing implies us that x is equal to 1 is a root. Now if x is equal to 1 is a root, it is being given that the roots of this equation, they are equal. It means that the roots of this equation, they are x is equal to 1 comma 1. It has repeated roots, and both the roots, they are 1 comma 1. Now we have to prove that this a, b, c, they are in HP. So we have to find the relation between these. So if we talk about the product of roots, it is 1 comma 1 we are saying, that is equal to c by a. So it is c into a minus b by a is a into b minus c. This term over here, this is just like a, this term is b, and this whole term is c, if we are writing it in the standard form. So from this equation, we are saying that a b minus a c, that is equal to a c minus c b. So this implies us that AB plus CB, that is equal to 2 times AC. So this implies us that the value of B is 2 times AC over A plus C. We are saying the value of B that we have, it is 2 times AC over A plus C, and this implies us that A, B, C, they are in harmonic progression. This is by the definition of the harmonic progression. Next is, if alpha is a root of this equation, we have to prove that 4 alpha cube minus 3 alpha is the other root. So if alpha is the root of this equation, suppose we are saying that the other root it is beta. We are saying if one root is alpha, other root is beta, then we have alpha plus beta is equal to minus b by a, that is equal to minus 2 by 4, that is equal to minus 1 by 2. So if alpha is one of the roots, the value of beta we obtain, that is equal to minus 1 by 2 minus alpha. From this equation we obtain this value. Now we have to reduce this, actually this is the root, and we have to write this value in terms of 4 alpha cube minus 3 alpha. So we start with this value. We are saying we want to form this number 4 alpha cube minus 3 alpha from 1 minus 1 by 2 minus alpha. So we are saying that we have 4 alpha cube minus 3 alpha, and we can write this as alpha into 4 alpha square minus 3. Now alpha is a root of this equation, this is given to us. So we can write that 4 alpha cube plus 2 alpha minus 1 is equal to 0. So this implies us that the value of 4 alpha, this is 4 alpha square, the value of 4 alpha square is equal to 1 minus 2 alpha. We substitute this value over here and we obtain this is equal to alpha into 1 minus 2 alpha minus 3. So this is equal to alpha into minus of 2 alpha minus 2. So this is equal to minus 2 alpha square minus 2 alpha. Now if we multiply and divide this equation with 2, we multiply this equation with 2 and divide this equation with 2, we obtain it is y, minus sign we are taking common, we are left with this 4 alpha square plus 4 alpha. Again we substitute the value of 4 alpha square from this equation. The answer we obtain it is minus 1 by 2 into 1 minus 2 alpha plus 4 alpha, and this value is equal to minus 1 by 2 into 1 plus 2 alpha, and this is equal to minus 1 by 2 minus of alpha, and this is what we have to prove, that this value is equal to beta is equal to minus 1 by 2 plus minus alpha, and we are saying this value is equal to minus 1 by 2 minus alpha, and this is equal to 4 alpha cube minus 3 alpha. So we are saying that if one root is alpha, then the second root is 4 alpha cube minus 3 alpha. Next is, if alpha and beta are the roots of this equation, it is lambda times x square minus x plus 5 is equal to 0. If lambda 1 and lambda 2 are the two values of lambda for which the roots alpha and beta they are related by this equation, then we have to find the value of lambda 1 by lambda 2 plus lambda 2 by lambda 1. So the given equation over here, it can be written in the form, it is quadratic equation, it is lambda x square minus lambda minus 1 x plus 5 is equal to 0, and it is given that alpha and beta these are the roots of this equation. So we will have the sum of the roots alpha plus beta, that is equal to minus b by a, that is lambda minus 1 by lambda, and the product of the roots lambda into beta is c by a, that is 5 by lambda. So these are the values we have over here. Now it is being given that these roots these are related by alpha by beta plus beta by alpha is equal to 4 by 5. So it is being given that alpha square plus beta square by alpha into beta is 4 by 5, and we know that the value of alpha square plus beta square, we can write it is alpha plus beta whole square minus 2 times alpha beta divided by alpha beta is 4 by 5. Substitute these values over here, we obtain alpha plus beta is lambda minus 1 by lambda square minus 2 times 5 by lambda divided by the value we have, it is alpha into beta, so that value will be 5 by lambda, and that is given to be 4 by 5. So if we simplify, if we try to simplify these values, we obtain this is equal to lambda square plus 1 minus 2 lambda, this numerator over here it is 10, and this will become minus 10 lambda divided by the LCM we have over here, it is lambda square into lambda by 5, that is equal to 4 by 5. So this 5 gets cancelled, one of these lambda gets cancelled. So the answer we have, it is lambda square minus 12 lambda plus 1 is equal to 4 lambda. So this implies as lambda square minus 16 lambda plus 1 is equal to 0. Now it is being clear that this equation, this is a quadratic equation, and it will have two values of lambda, and it is given that those two values, they are lambda 1 and lambda 2. There are two values, lambda 1 and lambda 2, and we have to write the relation, find the value of lambda 1 by lambda 2 plus lambda 2 by lambda 1. So clearly we have lambda 1 plus lambda 2, that is equal to 16, lambda 1 into lambda 2, that is equal to 1, that is sum of the roots and the product of the roots. We have to calculate the value of lambda 1 square plus lambda 2 square by lambda 1 into lambda 2. So that is equal to lambda 1 plus lambda 2 square minus 2 times lambda 1 lambda 2 by lambda 1 into lambda 2. And if we substitute these values, over here, we have the value of lambda 1 plus lambda 2 is 16, lambda 1 into lambda 2 is 1. When we substitute these values over here, we obtain the final answer as 254. So this is the required value of lambda 1 by lambda 2 plus lambda 2 by lambda 1, it is 254. Now next topic we have is transformation of quadratic equations. So if we have a quadratic equation, we are talking about ax square plus bx plus c, and the roots of this equation, they are alpha and beta, and these are the two real roots. Then we are saying, if we have to find the equation whose roots are alpha plus k and beta plus k, then what we have to do is, we have to replace x by x minus k. It means in this equation we are writing, the equation will be a into x minus k square plus b into x minus k plus c is equal to 0. Next is, if we want to find the equation whose roots are alpha minus k and beta minus k, then this equation will be in this form, that is x will be replaced by x plus k. If we want to find an equation whose roots are alpha k and beta k, then we have to replace x by k, and this will be the equation. When we replace x by k, this equation will become a times x by k square plus b times x by k plus c is equal to 0. If we multiply it with k square, we get it is a x square plus b k x plus c k square is equal to 0. So this is the equation whose roots are a times k and b times k. Next is, if we have to find the equation whose roots are alpha by k and beta by k, then we have to replace x by x into k. So if we want to prove this result, what we are going to do is, we are saying that we have to calculate the roots of this equation. So they will be minus bk plus minus k root of bk square minus 4ak square c upon 2ak square. So from this numerator part, if you look at this numerator part over here, this k is there, k square and k square is there. When we will take this k square common, when we take this k square common from this term, it is square root over here, we will get k. This k and k will get cancelled, all these k will be cancelled, and we are left with this 1k over here. So we are saying that the roots we are obtaining, they are 1 by k times this term. So we are saying the two roots we will have, it is alpha by k and beta by k. Similarly, if we want the equations whose roots are minus alpha and minus beta, so we are saying we will replace it with minus x. So in this case, the value of k we are saying that is equal to minus 1. Next is we have to find the equation whose roots are 1 by alpha and 1 by beta. So in this case, we have to replace x by 1 by x. So the equation will become a into 1 by x square plus b into 1 by x plus c is equal to 0. So this will give us a plus bx plus cx square is equal to 0. So this is the equation whose roots are 1 by alpha and 1 by beta. And similarly, for the equation whose roots, if we want to find the equation whose roots are minus 1 by alpha and 1 by beta, we have to replace x by minus 1 by x. And in this case, the equation will become cx square minus bx plus a is equal to 0. So we are saying the equation ax square plus bx plus c is equal to 0. It has roots alpha and beta. Then this equation has the roots minus 1 by alpha and minus 1 by beta. So now the quadratic equation that is given to us is ax square. Now the equation we have is ax square plus bx plus c is equal to 0. We are saying if the roots of this equation, they are alpha and beta, we want to write the equation whose roots are 1 by alpha and 1 by beta. The equation will be we obtain by replacing x by 1 by x. So it becomes a plus b x plus c x square is equal to 0. And now we have to write the roots of this equation. We are talking about this equation. The roots of this equation will be 1 by alpha and 1 by beta. Suppose we are saying these are gamma and delta. We are saying these roots, these are gamma and delta. Now we have to write the equation whose roots are k by alpha and k by beta. That is, we are talking about the equation whose roots are k gamma and k delta. Now what transformation we have to do? We have to replace the value of x by k. We have to replace this value. So when we substitute this value over here, the answer we obtain, that is a plus b into x by k plus c into x by k square equal to 0. So this gives us k square a plus b into x into k plus c x square is equal to 0. So we obtain this answer. So this answer, this is this value we are saying, that is a square k plus b k x plus c x square is equal to 0. Next is we have to write the equation whose roots are p alpha plus q and p beta plus q. So we are saying, first of all, we have to write, suppose the quadratic equation we are writing over here, it is ax square plus bx plus c is equal to 0. The same equation we are talking about, and we are saying its roots are alpha and beta. Now we have to transform it to the equation whose roots are p alpha and q beta. and then we have to transform it to the equation whose roots are p alpha plus q and p beta plus q. So what we have to do is we have to replace x by x minus q by p, and we obtain the answer in this form. Next is, if the equation, quadratic equation, has root alpha and beta, and we want to find the equation whose roots are alpha raised to the power n, beta raised to the power n, then we have to replace x by x raised to the power 1 by n. We are saying we have to replace x by x raised to the power 1 by n. So the equation will become, we have a x raised to the power 1 by n square plus b x raised to the power 1 by n plus c is equal to 0. So this will become, this term we are talking about the quadratic equation, so we are writing it in this form, that it is, this term it is x raised to power 1 by n, this term it is x raised to power 1 by n. So if we substitute x raised to power 1 by n is equal to t, this will become a t square plus b t plus c is equal to 0. And this last property that we have, it is, if we have to write the equation whose roots are alpha raised to the power 1 by n and beta raised to the power 1 by n, then we have to replace x by x raised to the power n. We have to replace this value, and the equation will be in this form, that it is a x n raised square plus b into x raised to power n plus c is equal to 0. So these are some of the transformations that we can make if we want to transform a quadratic equation with root alpha and beta to another equation whose roots are given in this way, that it may be k over alpha, k over beta, or it is alpha raised to power n, beta raised to power n. So some conditions on the roots are given, and we want to find the equations whose roots are in that particular form. So now we solve certain problems based upon these transformations. The first question we have is, if alpha and beta are the roots of the equation this, then we have to find the equation whose roots are in this form. So we are saying alpha and beta, these are the original roots, and these are transformed to the form p by this is q minus q by, not p by, this is q by p minus alpha and q by p minus beta. The equation given to us is x square minus px plus q is equal to 0. So if we replace, we are saying we require the root to be in this form, it means the value of x now we require. Suppose we are saying that the value of x we obtain from this, it is q minus p minus q over p minus alpha. So this gives us that p minus alpha is equal to q by x, and this implies us that the value of alpha we have, that is equal to p minus q by x. Similarly, the value of beta we will have, if we calculate the value of beta in terms of beta, we will have p minus q by x. So this is the transformation we have to use over here. So if we replace this value of x, by p minus q by x, the answer we obtain, it is p minus q by x square, then it is minus p into p minus q by x plus q is equal to 0. On opening the whole square, we obtain it is p square plus q square by x square minus 2pq by x, then minus p square, then it is plus pq by x, and it is plus q is equal to 0. So we obtain that this p square gets cancelled. If we multiply this whole equation by q square, the answer we obtain, it is, we multiply this whole equation by q square, the answer we obtain, it is with x square, the answer we obtain, it is qx square, this term we are saying, and then we are writing the terms with x. So that will be plus x into p into q into 1 minus 2, and then it is plus q square is equal to 0. So this value will become equal to minus 1. So we are saying the equation we will have, that is x square minus, we are dividing this whole equation by q, we are dividing this whole equation by q, or we are saying we take q common. So this q is cancelled. Next we have is, it is minus 1, this q is cancelled, this q is cancelled. So the answer we are left with is x square minus p times x plus q is equal to 0. This is the final answer we obtain. So the transformation we have done over here, it is alpha is equal to p minus qx, that is x is replaced with p minus qx. Next is, if alpha and beta are the roots of this equation, then find the roots of the equation this. We have to solve this equation. The given equation is, we are writing it over here, it is ax square minus bx into x minus 1 plus c into x minus 1 square is equal to 0. If we divide this whole equation with x minus 1 square, the equation will become x over x minus 1 square minus bx over x minus 1 plus c is equal to 0. Now if we consider a quadratic equation, say we are talking about ax square plus bx plus c is equal to 0, and we are saying that alpha and beta are the roots of this equation, then we are saying if we substitute alpha is equal to x over 1 minus x, beta is equal to x over 1 minus x. So if we use this transformation we are talking about, if we replace x with x over 1 minus x in this equation will be transformed to this form. We are saying we have replaced x with this value, suppose x square, we are saying we have replaced it with x over x minus 1, we have replaced this x with x over x minus 1. This equation, this quadratic equation will be transformed into this form. It means we are, what we have done, we have changed the roots. And how the roots are being changed, if we calculate the value of x from this, we are saying 1 by alpha is equal to 1 by x over x. So this implies us 1 by alpha is equal to 1 by x minus 1. So this implies us that 1 by x is equal to 1 by alpha plus 1. So this implies us that the value of x we have, that is equal to alpha over 1 plus alpha, and the value of this implies us the value of x is beta over 1 plus beta. So if the roots of this equation they are alpha and beta, then the roots of this equation will be alpha over 1 plus alpha and beta over 1 plus beta. Now the next we have is, if alpha and beta are the roots of this equation, then we have to find the value of this term. So one method is that you calculate the roots over here. You calculate x is equal to minus b plus minus square root of b square minus 4ac. So that will be 12 over 2 into 3. So this is equal to minus 2 plus minus iota 2 root 2 by 3 into 2. So this is equal to minus 1 plus minus iota root 2 by 3. So the value of two roots we have, alpha is minus 1 plus iota root 2 by 3 and beta is minus 1 minus iota root 2 by 3. Now what we have to do is, we have to substitute these values of alpha and beta over here, and we have to solve this value, and it will be very lengthy procedure. So in place of doing this thing, we are going to use some transformation to solve these kind of problems. Now if we look at this term over here, it is 1 minus alpha over 1 plus alpha, and if we substitute it equal to x, we obtain, we apply componendo, dividendo, and we obtain it is x plus 1 over x minus 1, that is equal to 1 minus alpha plus 1 plus alpha over 1 minus alpha minus 1 minus alpha. So over here this alpha gets cancelled, 1 gets cancelled. So this implies us that 1 over alpha, that is equal to 1 plus x over 1 minus x. So this implies us that the value of alpha is 1 minus x over 1 plus x. So this thing means that if we replace x by 1 minus x over 1 plus x, if we replace x by this term, then this equation, in this equation, then the transformed equation will have the roots 1 minus alpha over 1 plus alpha and 1 minus beta over 1 plus beta. So if we substitute this value over here, we will obtain it is 3 into 1 minus x over 1 plus x square plus 2 into 1 minus x over 1 plus x plus 1 is equal to 0. On solving this, we will obtain it is 3 into 1 minus x square plus 2 into 1 minus x into 1 plus x plus 1 plus x square, that is equal to 0. On solving this equation, we will obtain it is x square minus 2x plus 3 is equal to 0. This is the equation whose roots are, we are saying this is the equation whose roots are 1 minus alpha over 1 plus alpha, 1 minus beta over 1 plus beta. So we are saying its roots there 1 minus alpha over 1 plus alpha and 1 minus beta over 1 plus beta. Now if we calculate the sum of the roots, we are talking about 1 by alpha by 1 plus alpha, 1 minus beta by 1 plus beta. The sum of the roots will be minus b by a, so that will be 2. And if we calculate product of roots, that will be 1 minus alpha over 1 plus alpha, 1 minus beta over 1 plus beta, that will be equal to 3. So we are talking about these two values. We are saying 1 minus alpha over 1 plus alpha plus 1 minus beta over 1 plus beta is 2, 1 minus alpha over 1 plus alpha into 1 minus beta over 1 plus beta is 3. Now we have to calculate the value of this term. We are talking about it is 1 minus alpha over 1 plus alpha cube plus 1 minus alpha over 1 plus beta cube, and we are applying the formula over here. We know that how we calculate the value of alpha cube plus beta cube. We use the formula, it is alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. So we have written it is alpha plus beta whole cube minus 3 times alpha beta into alpha plus beta. Now we have the value of all these terms. We have the value of all these terms. We have the value of alpha plus beta, that is 2. We have the value of 1 by alpha, alpha minus 1 over 1 plus alpha into 1 minus beta into this, the value we have it is 3, and again the sum of these two values it is 2, and on solving all these values the answer we obtain, that is equal to minus 10. So this is the answer we obtain for this expression. Next is we have roots under some special cases. So we are talking about a quadratic equation ax square plus bx plus c is equal to 0, where a, b, c these are real numbers and a we are saying it is not equal to 0 because it is a quadratic equation. Then the first condition we are talking over here, it is that if this equation, the roots of this equation are equal in magnitude but opposite in sign, that is we know that the roots of this equation they are minus b plus square root of b square minus 4ac by 2a, it is plus minus over here. So one root is minus b plus square root d by 2a, and second root is minus b minus square root d by 2a. First condition we are saying is they are equal in magnitude but opposite in sign. So we are saying the sum of the roots is 0. We are saying if the two roots we are saying they are alpha and minus alpha. So this implies us that alpha plus minus alpha is equal to 0, and sum of the roots it is given by minus b by a. Minus b by a is 0. This implies us b is equal to 0. So if we substitute b is equal to 0 over here, the roots will be square root d by 2a and minus square root d by 2a. So what we have is that b is equal to 0 and d is greater than 0. Second is if they are reciprocal of each other. So we are saying one root is alpha, another root is 1 by alpha. The answer we will have 1, that is equal to c by a. So this thing implies us a is equal to c and d is greater than equal to 0. In this case we are saying d is greater than 0. In this case we are saying d is greater than equal to 0 because over here we require them to be of opposite sign. If d is equal to 0, both roots will become 0. They are not of opposite sign. But in this case we are saying d is greater than equal to 0 because we require them to be, we do not have the condition that they should have opposite sign over here. So we are just saying that we have the condition that d is greater than equal to 0. It means they have the real roots, and this condition is because of they are reciprocal of each other. Next is if the roots of the equation are of opposite signs, the product of roots is less than 0. We are saying if they are of opposite signs, that is one is alpha and another is minus beta. We are saying alpha and beta, these are two positive real numbers, and the roots they are in the form alpha and minus beta, that is they have the opposite signs. Then we have the product of the roots alpha into minus beta, it is less than 0, and we have d is greater than 0 because it will have real roots. We are saying d is greater than 0. So we are saying that a is greater than 0, c is less than 0 and d is greater than 0. Why we are saying so? Because of this condition we will have c by a, this should be negative. So we have two conditions, when c is less than 0, in that case a is greater than 0, and when c is greater than 0 we have a is less than 0, and this condition d is greater than 0 is there in both the cases. Next property we have is that if both roots of equation 1 are positive, we are saying one root is alpha, another root is beta, both these values these are greater than 0, then the sum and product of the roots, it is greater than 0. We have alpha plus beta is greater than 0, alpha into beta is greater than 0, and the condition we have is d is greater than equal to 0 because both the roots they are real. So from these conditions we can say alpha plus beta is greater than 0 means minus b by a is greater than 0, c by a is greater than 0. So this gives us that a and b are of opposite sign and a and c are of same sign, and last condition we have is d is greater than equal to 0. Next is if both roots of the equation are negative, we are saying one is minus alpha, second is minus beta, both of these are negative, then the sum of the roots we have minus alpha minus beta is less than 0, minus alpha into minus beta is greater than 0. So this gives us minus b by a is less than 0, this gives us c by a is greater than 0. So this thing implies us that a, b, c, all these three are of same sign, all these values are of same sign, and the condition for d we have it is again d is greater than equal to 0. Next is if greater root in magnitude of equation 1 is positive. Suppose we are saying that alpha is greater than beta and we have alpha is positive, then the sign of b is equal to sign of c is not equal to sign of a. We will have alpha plus beta that is equal to minus b by a, and alpha into beta that is equal to c by a. Now we have the greater root, we have alpha is greater than 0. We are given that this alpha is positive. So from this condition we will have this value is greater than 0. This is always greater than 0 irrespective of beta is positive or negative. So if this value is greater than 0, so what we obtain is that A and B are of opposite sign. These are of opposite sign. And if beta we have, it is this beta we are saying, we are having two conditions over here. One is either beta is greater than 0 or we are saying beta is less than 0. In that case we will have this C over A over here. So if beta is greater than 0, it means alpha into beta is greater than 0, C over A is greater than 0. So A and C are of same sign. And if beta is less than 0, then we are saying that C by A is less than 0, then A and C, these are of opposite sign. So if we are saying that the greater root is positive and smaller is negative, then we have the condition that sine of B is equal to sine of C is not equal to sine of A. Now next we have is if greater root in magnitude of equation is negative. So we are talking about, in the previous case we are saying that the greater root was positive, now the greater root it is negative. Suppose alpha is greater than beta and we are saying that the greater root is negative. And it is being given that alpha is greater than beta, then beta is automatically negative. So we are saying that sum of the roots alpha plus beta, we are saying that will be negative and alpha into beta will be positive. So this means minus B by A is negative and C by A it is positive. So this thing means that the sign of A and B, they are equal and sign of A and C, they cannot be equal. So we are getting that sign of A is equal to sign of B is not equal to sign of C. Next is if both roots of equation 1 are 0. So we will have B is equal to C is equal to 0. If both roots are 0, then sum of the roots minus B by A is 0. Product of the root alpha into beta is C by A is 0. So this implies us that B is equal to C is equal to 0 and A cannot be equal to 0 because it is a quadratic equation. Next is if the roots of the equation are 0 and minus B by A. If these are the two roots, one is 0 and one is minus B by A, then the sum of the roots we have, it is 0 minus B by A is equal to minus B by A. And the product of the roots we have, it is 0 into minus B by A is equal to 0, that is equal to C by A. So this implies us that C is equal to 0. And last is if the roots of the equation are 1 and C by A, then we have the sum of the roots is 1 plus C by A, that is equal to minus B by A. So this implies us that A plus C by A is equal to minus B by A, and this implies us that A plus B plus C is equal to 0. We are saying A plus B plus C is equal to 0. So we are saying that if the coefficients we have A plus B plus C is 0, then one of the roots we can say it is 1. Now based upon this we have this problem. So it is for what values of m being real, this equation is given, we have to find roots are equal in magnitude but opposite in direction. So first of all we are saying we have to put the condition for the roots to be real, only then we can talk about the signs of the roots. So the roots we have the d value of d discriminant we have, it is b square, it is 4 into m minus 1 square minus 4ac, it is 4 into m plus 5 we are saying. So this is equal to, when we solve this value we obtain, it is 4 times m square minus 3m minus 4. This is equal to 4 times m minus 4 into m plus 1, and we are saying that this value should be greater than 0. We are saying it should be greater than equal to 0. First part we have, it is that roots are equal in magnitude but opposite in signs. So we know that if the roots are equal in magnitude and opposite in sign, then the sum of the roots, that is 0, that is minus b by a is 0. So this implies us that the value of b is 0. So if the value of b is 0 and d is greater than 0, this equality sign should not be there. So we will have two conditions now. First is b is greater than 0 means b is equal to 0 means 2m minus 1 is 0, and second we have is 4 into m minus 4 into m plus 1 is greater than 0. So this gives us the value of m we have, that is equal to this is 2 times m minus 1. So the value of m we have, that is equal to 1. And if we substitute this value of m in this equation, if we substitute the value of m in this equation, we obtain it is 4 into 1 minus 4 into 1 plus 1, that is equal to negative number. So we cannot find a value of m, we have and in between these two, we cannot find a value of m which satisfy both these conditions. So we are saying that m belongs to the null set. There is no m for which this condition holds, that this equation cannot have roots equal in magnitude but opposite in sign. Second part is roots are reciprocal of each other. So if roots are reciprocal of each other, we are saying the roots of this equation, they are alpha and 1 by alpha, and that should be equal to 1, that is equal to c by a. So this implies us that c should be equal to a. So c should be equal to a means we are saying that m plus 5 should be equal to 1. So this implies us that the value of m we have, that is equal to minus 4. And if we substitute this m is equal to minus 4 in this equation, we will obtain it is, in the equation of discriminant we are substituting, it is 4 into minus 4 minus 4 minus 4 plus 1. The answer we obtain over here, it is a positive number. We are saying the answer we obtain over here, it is a positive number. This whole term will be negative, this term will be negative, negative into negative will be positive. So it means it satisfies the condition that d is greater than 0. So we are saying for m is equal to minus 4, this equation will have roots which are reciprocal of each other. Next is roots are opposite in sign. We are talking about the roots which are opposite in sign. So we are saying there are two roots, say alpha and minus beta, they are opposite in sign. So in this case we have seen that the product of roots, when we are saying alpha into minus beta, that is equal to c by a, it should be less than 0. It means we are saying that c and a should be of opposite sign. So clearly the value of a is equal to 1, it is greater than 0. It means the value of c should be less than 0 and the value of discriminant should be greater than 0. So if we put the values over here, we are saying c is less than 0 means we are talking about m plus 5 is less than 0. So we are saying that m is less than minus 5, and if we solve the equation for this discriminant, we are talking about this equation, 4 times m minus 4 into m plus 1 is 0, we obtain the answer in the form that m belongs to minus infinity to minus 1 union 4 to infinity, and the common value we have over here, the common region we have over here for these two cases, we are saying m is less than minus 5, m belongs to this interval, the final answer we obtain, it is m belongs to minus infinity to minus 5. Now the next case we have, both roots are positive. So if we are saying both roots are positive, so we are considering the roots to be alpha and beta, and both of these are greater than 0, then clearly we have alpha plus beta is equal to minus b by a should be greater than 0. So we are saying we have the condition over here that a and b should have opposite signs, a comma b, they are of opposite sign because of this minus sign, we are saying they are of opposite sign. A is clearly positive, we are saying a is positive, so b is negative, we are saying b is negative. So b is negative means we are talking about 2 times m minus 1 is less than 0. So this implies us that m is less than 1. Now if we take the product of the roots, we are saying alpha into beta, that is equal to c by a, this should be also greater than 0. It means A and C, these are of same sign. So we get that the value of C is positive. C is m plus 5 is greater than 0. It means m is greater than minus 5. So the value of D we have, it is greater than 0, and for D greater than 0 the answer is, the region we have, it is minus infinity to minus 1 union 4 comma infinity. In this case we are saying that A and B, these are positive, so we have the condition over here, they are greater than equal to 0. So we have closed intervals over here, So the common region to all these three, we are saying we have the first region we are talking about, it is m is less than 1, m is greater than minus 5, and this, we are having these regions, and the common region to all these values, it is m belongs to the interval minus 5 comma minus 1. So for these values, or the roots will be positive. Next is the roots will be negative, that is both roots we are saying they should be negative. So in that case we are saying that the roots we have alpha and beta both are less than 0. So alpha plus beta is less than 0, alpha into beta is greater than 0, minus b by a is less than 0, and c by a is greater than 0. So if b by a is less than 0, it means that a and b should have same sign. So this implies us that b is greater than 0. A and C should have same sign, we are saying C is greater than 0. B is greater than 0 means that m minus 1 is greater than 0. This implies us m is greater than 1. C is greater than 0 means m plus 5 is greater than 0. This implies us m is greater than minus 5. Common region to both these is, for these two values, the common value we have, it is m is greater than 1. The value of D we have, the region for D we have, D greater than equal to 0, it is this region. So the answer we obtain is, now the regions we have, it is m is greater than 1, m belongs to this interval. So the common region we have over here is that m belongs to the interval 4 comma infinity. Now the next case we have is that at least one root is positive. So when we are saying one root, at least one is positive, it means first case we have is either one is positive, one root is positive, or second we are saying both roots are positive. So we have already seen that if we are saying that either one root is positive, it means we are saying that one root is positive means that the roots, they are of opposite sign. So this is the case 3 we have seen, and in this case the answer we have, it is minus infinity to minus 5. And when we are saying that both roots are positive, it is the case we have already seen, and the answer we have, it is minus 5 comma minus 1. So if we are talking about that either of these cases should hold, so we are saying that we are talking about the union of these two. So the answer we obtain, it is minus infinity to minus 5 union minus 5 to minus 1. Similarly, the last case we have is that at least one of them is negative. So when we are saying at least one of them is negative, it means that one root is negative. We have either this case, or we are saying two roots are negative. So when we are saying one root is negative, it means roots are of opposite sign. We are saying roots are of opposite sign, and this is again the case we have already discussed, and the answer we have, it is minus infinity to minus 5. And when we are saying that two roots are negative, this is the case we have discussed, and the answer we have, it is 4 comma infinity. So the union of these two intervals, union of these two will give us the answer for either one root is negative or both are negative. So the answer we obtain, it is minus infinity to minus 5 union 4 comma infinity. So this is the values of m, these are the values of m for which either one root is negative or both roots are negative. Next we have to calculate is the condition for common roots. So suppose we are saying we have two equations, one is ax square plus bx plus c is equal to 0, and second is a dash x square plus b dash x plus c dash is equal to 0. These are quadratic equations, so we have a and a dash, these are not equal to 0. And further we have the condition that a b dash minus a dash b is not equal to 0. It means we are saying that a by a dash is not equal to b by b dash. Why this condition is there, this will be more clear to you when we will move on to our next slide. So right now we are just assuming this condition. So we are saying if both these equations have a common root, and let that common root be alpha, then this alpha satisfies both these equations. So we have a alpha square plus b alpha plus c is equal to 0, a dash alpha square plus b dash alpha plus c dash is equal to 0. So by cross multiplication we can write alpha square, alpha and 1. The coefficients we will have over here bc dash minus bc dash. So we have over here, if we look at these values, these are bc dash minus b dash c, and c dash a minus ca dash, and a dash b minus a dash b. So this value is this is b dash c. This value is not bc dash, this is b dash c. Similarly, for this value alpha we will have c dash a minus c a dash, and for 1 we have it as a dash b minus a b dash. So if we solve these first two equations, we will obtain the value of alpha is equal to b c dash minus b dash c divided by c a dash minus c a dash, and the value of beta this alpha from these next two equations we are talking about. If we calculate the value of alpha from the next two equations, we are saying these two equations, the answer we obtain, it is alpha is equal to c dash a minus c a dash over a dash b minus a b dash. Both these values of alpha should be equal. So the final condition we obtain over here, it is in the form this, that is b c dash minus b dash c over c a dash minus a dash c, that should be equal to c a dash minus c dash a over a dash b minus a b dash. And this condition, it can be written in the matrix form in this way. So this is the condition for two equations to have a common root. Next is, if both the roots are common, then we are saying the equations we have, it is ax square plus bx plus c is equal to 0, and a dash x square plus b dash x plus c dash is equal to 0. If both the roots are common, and if we write the sum of the roots over here, we will have the sum of the roots alpha plus beta, that is equal to minus b by a, that is equal to minus b dash by a dash, because alpha and beta we are saying they are the roots of both these equations. So sum of roots they are equal. So this implies us that a by a dash is equal to b by b dash, and the product of the roots should be same. We are saying alpha into beta, that is equal to c by a is equal to c by c dash by a dash. So this implies us a by a dash is equal to c by c dash. So combining these results, we obtain that a by a dash is equal to b by b dash is equal to c by c dash. If this condition holds, then we say that both the roots they are equal. Now this condition we are talking about, this is just the condition we have already seen in our previous question, where we have assumed that a by a dash is not equal to b by b dash. This is the condition corresponding to this. That is why we have assumed over there that a by a dash should not be equal to b by b dash. So we are giving over here the method how to find the common root between two equations. We are saying to find the common root between two equations, what we have to do is we have to make the coefficients of x square in both the equations equal. We make the coefficient of x square in both the equations equal, and then subtract the two equations. and then we subtract the two equations, and hence we obtain the common root between the two quadratic equations. Now the next question we have is find the value of lambda so that these two equations they may have one root in common, and we have to find that common root. So if we look at this first equation, x square minus x minus 12 is equal to 0. We are saying the roots of this equation we can find it is x square minus 4x plus 3x is minus 12 is equal to 0. So this implies us that the value of x we have, this is 4 and minus 3. Now if we consider that 4 is the common root, x is equal to 4 is common root, it means this is the root of the equation lambda x square plus 10x plus 3 is equal to 0. So we get lambda into 4 square plus 10 into 4 plus 3, they should be equal to 0. So on solving this value will become 40 plus 3. So the answer we obtain it is, this value is 40 plus 3. So the answer for lambda we have, that is equal to minus 43 by 16. So we are saying for lambda is equal to minus 43 by 16. These two equations will have a common root, that is x is equal to 4. Next we have is if x is equal to minus 3 is the common root, then we will have lambda into minus 3 square plus 10 into minus 3 plus 3 should be equal to 0. So we obtain 9 lambda minus 27 is 0. So we obtain the value of lambda is equal to 3. So we are saying for lambda is equal to 3, the common root is minus 3, and for lambda is equal to minus 43 by 16, for lambda is equal to minus 43 by 16, the common root it is x is equal to 4. Next is if the equations, this equation is ax square plus bx plus c, abc these are real, and it is given that a is not equal to 0. It is being given that a is not equal to 0. And the second equation that is given to us is x square plus 2x plus 5 is equal to 0, have a common root. Then we have to show that a is to b is to c is equal to 1 is to 2 is to 3. Now if we look at this second equation, if we look at this equation, the value of d we have, first thing is that its coefficients they are real. The value of d we have, it is b square minus 4ac, it is negative. It means the roots of this equation will be if one root is a plus iota b, it is imaginary root, then the other root will be a minus iota b. Now we are being given that this equation it also has real coefficients. So if one root is common between these two, if one of the roots of this equation is a plus iota b, then automatically the other root will be a minus iota b. And we know that it means both the roots of these two equations they are equal. And we know that if we have equation ax square plus bx plus c is equal to 0, second is x square plus 2x plus 5 is equal to 0, and if they have the both roots they are common, then we have a by 1 is equal to b by 2 is equal to c by 3. So this is the required condition. We are saying that the ratio of a is to b is to c, that is equal to 1 is to 2 is to 3. We obtain that their ratio there 1 is to 2 is to 3, because they are both their roots they are equal. But this condition that they should be real, their coefficient should be real, is important over here. Without this we cannot say that if one result is one root is a plus iota b, the other is a minus iota b. Next is if a, b, c are in GP, three numbers are given to us, a, b, c, they are in GP. We have to show that the equations, one equation is ax square plus bx plus c is equal to 0. Second is dx square plus 2ex plus f is equal to 0 have a common root if a by d, b by e and c by f are in harmonic progression. So the two equations that are given to us, it is ax square plus 2bx plus c is equal to 0. Second is dx square plus 2ex plus f is equal to 0. It is being given that a, b, c are in GP. So it means b is equal to square root of AC. You can substitute this value over here. So this equation becomes ax square plus 2 square root of acx plus c is equal to 0. and this is the equation for, if we write this as whole square, this as whole square, we are saying this is the equation square root of ax plus square root of c whole square is equal to 0. It means x is equal to minus root c by root a comma minus root c by root a. Now we are saying that they have a common root, both the roots they are same. If they have a common root, it means both their roots they are same. So what we obtain from this is that this value we are saying square root minus square root of c by 8 is the root of this equation, so it should satisfy it. So we are saying d into c by a plus 2e into square root of c by a, it is minus sign over here, plus f is equal to 0. So we are writing this in the form, it is d by a plus, and this is minus sign over here, this is not plus sign, this is minus 2e by square root of ac plus f by c is equal to 0. And what is square root of ac? The value of square root of ac we have, that is equal to b. So this thing implies that d by a minus 2e by b plus f by c is equal to 0. We obtain this result. Look at this result over here. This thing proves that the three numbers a by d, b by e and c by f, these three numbers, they form an harmonic, they form a harmonic progression, they are in harmonic progression.